Hello everyone, and greeting to my lecturer, Dr. Rashida. We are from Numerical Methods Section 2, Group 2, and we are going to present our group assignment. This is our group member. My name is Tong Kim Yao, and my metric number is AE230070. Since we are from Group 2, we are going to present the title System of Linear Equation. There are two different methods to solve the system of linear equations, which are Gauss elimination method and Gauss elimination with pivoting. The Gauss elimination method converts the system into an upper triangular matrix through row operations and use substitution to find the unknown value. The Gauss elimination with pivoting set the rows so that the largest absolute value in the current column becomes the pivot. So this is the engineering problem that we found. We need to analyze the circuit with the value given R equals to 30 ohm and the voltage V equals to 20 volt and the current source A equals to 10 ampere. Then we need to find the nodal voltage V1, V2, V3 and also the V4. So now I will present the manual calculation part. Firstly, we label each circuit line IX, I1, I2, I3 until I6. For the method 1, using Gauss elimination method, at the node V1, we apply the KCL method, which is I1 equals to IX plus I2 plus I3. And at the node V2 and V3, we apply supernode, where the V2 minus V3 is equal to 10IX. And then at the node V2 and V3, we apply the KCL again, which is I3 equals to I4 plus I6 plus I5. After that, we solve and simplify the three equations, and we will get these three simplified equations. After we simplify the equations, then we convert it into the matrix form. So next, we need to eliminate this matrix form row by row, and we will get the triangular upper matrix, which means the left side corner have 3 0 here. After we get the upper triangular matrix, we can use the substitution method to find the V3. For example, this is the value of V3 is equal to negative 389, and then we will get the value of V3 equals to 11.37. After that, we apply the same method for the second equation and the first equation, and we will get V1 equals to 53.57 volt, V2 equals to 22.56 volt, and V3 equals to 11.37 volt. V4 is equals to 20 volt is because the nodal V4 is no resistor. Then the voltage is equal to the voltage source, which is 20 volts. So next is for the method 2, Gauss elimination with pivoting. The method is similar to the Gauss elimination method, but the only difference is when we eliminate the matrix form. We need to make sure the top column number have the largest number, which is 17 is larger than the 1 and 12, so we can start to eliminate it. After that, we need to compare among these two numbers. The 18 is larger than 2, so we need to set the row 2 and row 3 become this. Then we can start the elimination. After we get the upper triangular matrix, we can do the substitution to get the value of V1, V2, V3, and also V4. Next, we will simulate the circuit to validate our manual calculation. Okay, so this is our simulation by using the Simulink in the MATLAB software. After we've set up the value and built the components, we run the program. After we run the program, the given value result is same with our manual calculation. This is proof that our manual calculation is correct. Thank you. That's all from me, and I will pass the present to next presenter.
A very good day to everyone. My name is Leon Jie, and my metric number is AE230060. Today, we are going to present how to use MATLAB to solve a system of linear equation obtained from manual calculation using the function elimination method. This approach allows us to verify each step of the manual process, helping to boost our confidence and deepens our understanding on how Gaussian elimination works. By comparing output with our manual step, we can make the learning process more interactive, actual, and engaging. Now I'll begin to explain each part of the manual code that we use to perform Gauss elimination. These are the code that we use to perform Gauss elimination method to solve the system of linear equation that we obtain from the manual calculations. First, I will define the matrix and vectors using these codes. A is the coefficient matrix, B is the right hand side of column vectors, N is the number of unknowns. In this case, our questions that we want to find is V1, V2, V3. After that, we will use this code to print out our initial matrix A and B to show the starting point for our software. Code is for forward elimination steps. This code is meant by forward elimination loops. K is outer loops, pick the private rows. For I is target all the rows below the private to eliminate values in columns K. And for this code is calculate the elimination factors. This is the multiplier used to eliminate the element in row I and columns K. The factor that I just now said the code is mean by this, like A21 over A11. After this code will help us to print out this is the code to print out the element stats to show which element is being eliminated and what factors is used. Help to visualize the step-by-step process. And this code is used for show before eliminations. And this code is used to perform row operations. After performing row operations, and this code will help to display the result after performing the row operations. And this code to show the upper triangles matrix. Once the eliminations are done, this shows the final upper triangle matrix. And this code to show the back substitutions. It will start with the last variables, initialization solutions vector x, and solve the last variables which only have one unknowns. It is used for back substitutions remaining variable. After we find the x, they have one unknowns. After we find it, the value, if we use it to solve another to find another's x values like x1, x2. And this goes to is to print out the final values after we obtain from these substitutions. And this is our code. Then I will start to run. It will appear the result like this. First, it will define the matrix A and B. This is the matrix A. This is matrix B. Come from these codes, and it will print out with the L of these codes. After that, it will perform the eliminations. This is before. It from this code, and this is a row that we need to eliminate. Is the row is A, second columns first row, and the factor we use is 0.05882. After performing the row operations from this, we will get the new row 2 is 0, negative 2.2941 and 3, and the right hand side is negative 17.6406. After that, it will do so on until it will get the upper triangles. It will update like this. Then the right hand side is 640 and negative 17.6471 and negative 389.2308. From here we will do the back substitutions with the add of these codes. It will use the this row first to find the S3 first, and then after obtaining the S3, the code will move from here to find the following x2 and x1. After that, after we obtain all the value, we will get the final. It will print out the final results. V1 we will get 53.57. V2 we get 22.57. V3 we will get 11.37. V4 we will get 20. This is we get from the questions. Then we can check our manual calculation whether we do correct. Since it is the same, then our manual calculation is performed correctly and do solving correctly. And that's all for me. Thank you.
Hello everyone, my name is Kai. My matrix number is AE230076. Now I will show that how to use MATLAB to solve the Gauss elimination with pivoting method. First of all, we need to obtain the matrix form, which the linear equation. We need to convert the linear equation from the manual calculation into the matrix form. And then this one is the code that we type. And then next step, we need to type in the code about the forward elimination with pivoting. This code is about the partial pivoting. And then this one is about the elimination code to eliminate the value to the 0. And then the next code is about the back substitution. Actually, this one back substitution is need to substitute back the values, and then need to get the final result. Okay, then I will run this coding. After you run this coding, it will show the result on the command window. Now I will explain about the command window. Okay, first this first part is the initial matrix A and B, and actually this one is obtained from the coefficient matrix A and right hand side vector B. And then next is about the eliminating on the row 2 column 1 using the row 1 vector. And then before the row 2 is 1, -3, and 3. After we eliminate, the answer will give 0 and -2.2941 and 3. After that, we will need to eliminate the column 3, row 1. Before the row 3 is 12, -27, and -10. After we eliminate, we will get the answer is 0, -18.5294, and -10. And then after that, we need to swapping. Okay, before that, the row 3 one we need to swapping because this one is the pivoting method. And then we need to swapping because we need to allow the row 2 become the biggest value. Okay, now the row 3 is -18.5294, which is bigger than the -2.2941. Therefore, it's swapped between the row 2 and row 3. After swapping, the matrix form is shown like this. And then next we can continue to, after swapping, we can continue to solve the eliminating. Okay, now we need to eliminate the row 3 column 2. After we eliminate, we'll get the row 3 is 0, 0, and 4.2381. Okay. Then after eliminate, the final result, the matrix form is show like this on the command window. After that, we need to use the back substitution, which is the coding from this. After we substitute back, then it will show the final result is the V1 is equal to 53.57, and the V2 is equal to 22.56, V3 is 11.37, V4 is 20 volt. I will show that this one MATLAB M file is actually same with the manual calculation. It's proof the results are the same. That's all from me. Thank you.